Hey everyone, I'm Ujjwala, and today we are diving into TCP/IP socket programming, the secret sauce behind how computers talk on the internet. We'll learn how to build network applications that send and receive data securely, and even code a client server project for authentication. So, buckle up and get ready to unlock the power of network communication with me. So let's understand what TCP/IP is. So TCP/IP is a suite of communications protocols used to connect hosts on the internet. It's named after two of its most prominent protocols, the Transmission Control Protocol and the Internet Protocol IP. The TCP/IP provides end-to-end connectivity specifying how data should be packetized, addressed, transmitted, routed, and received at the destination, the foundation of internet communication. So these protocols form the backbone of internet communication, guiding data packets to the right destination efficiently. Hierarchical networking model. So this model breaks down network interactions into layers like link, internet, transport, and application layers. So let's understand the importance of socket programming. So sockets enable applications to connect over the networks using protocols like TCP or UDP, which is User Datagram Protocol, for reliable data exchange. Interface for network communication. Sockets serve as the interface for applications to request network services and exchange data. Supports various protocols. So socket programming supports various protocols tailored for reliability, TCP or speed, UDP. Goals. So we have understanding network fundamentals. So this project that we'll be discussing about deepens our understanding of data structure, addressing and routing across the networks, and developing practical skills. So hands-on experience in C is essential for creating network applications, which is our programming language for this project today. Secure communication implementation, so ensuring authenticated client-server interactions and data integrity. Now let's go to the client-server model. We have model definition, so which is nothing but a structure dividing tasks between servers and clients, where clients initiate the communication sessions. And then we have TCP/IP facilitation. So the TCP/IP ensures reliable, ordered, and error-checked data delivery. Roles in communication. Understanding the various roles in communication is essential for effective information exchange and collaboration in any organization. The project specifications. So let's get into the details of the project that we'll be, working on today. So in this project, we are required to do socket programming in C language to implement a pair of client and server that can achieve simple password verification to indicate the account number and balance. So the client will send a pair of user ID and password to the server, and the server will verify whether the pair of user ID and password is legitimate or not for retrieving the account number and balance. Assume only the legitimate pairs of user ID and password that will be accepted by the server as follows. So these will be the five pairs of user ID and password we will be using. These are the associated account numbers and balance. Now let's move on to the requirements of the client and servers today. So the client program requirements are that the client program must accept two command line arguments, the server's name and the port number to connect to. And the command line argument should specify the server's host name or IP address and the port number. The server program requirements, the server program should accept one command line argument specifying the port it will listen to. The port number should be specified at as the command line argument for the server program. Server initialization, the server should start first and continuously listen to the specified port for incoming connections. Client server connection, the client program must establish a connection to the server using the provided server name and port number. Upon successful connection establishment, a socket connection between the client and server should be created. User identification, after successful connection, The server should prompt clients to join for account number and balance retrieval. The client program should display a prompt for the user to enter a user ID. User authentication. Upon receiving the user ID from the client, the server should acknowledge the receipt with a message. After acknowledgement, the client should prompt the user to enter the corresponding password. Verification of credentials. The server should verify the received user ID and password against the list of legitimate pairs. So if the credentials match, then the account number and the balance are displayed to the client. If the credentials do not match, the server should send a failure message to the client. Response handling. Upon receiving the result message from the server, the client should print the account number and password. So after printing the result, the client should send a quit message to close the socket connection. The socket closure. So the server should close the socket after either waiting for 30 seconds for user ID or the password input. The server should also close the socket after responding to the client's request and waiting for the next client connection. And now that we have seen the discuss the overview of how the project is going to be like, let's understand in depth the technical aspect of it, which is the coding. So we will discuss the server code first. So this is a server code in C language. So initially we have the environment setup and library inclusion. So the libraries like stdio, stdlib, string, and unistd. So these are all included for basic input output, string operations, and system calls. And then we have Windows specific, which is winsock 2.h. So it is included for socket programming with initialization done using WSA startup. And then we have data structures and constants. So we have buffer size. It is defined to set the maximum size for message buffers. And then we have user record. So this is a structure that holds user data, including ID, password, account number, and balance. And then we have user authentication function. See, the authenticate user here checks provided credentials against stored user records and returns the matching records or null if not found. That is what we are doing here. And then we have socket creation and setup. So we have create server socket here. So this is a function that is used to create a TCP socket. And similarly, we have set socket options. I would I had mentioned the comments for almost each and every lines in the code here. So if you missed out any point, please feel free to pause and take a look at the codes briefly again, because I'll be just giving an overview of the code that I had written right now. So the set socket options, this function sets the options on the server socket to reuse the address. And then we have bind socket. So bind socket is again binds the socket to the specified port, allowing it to listen for connections, that particular port. And then we have listen for connections. So this configures the server to listen for incoming connections. And then we have accept connection. So accept connection waits for and accepts an incoming connection, returning a new socket for client server communication. And then we have the biggest, the most beefy function over here would be handle client communication. So because this manages the communication with the connected client, handling user ID and password, authentication and session management all together. So it sends initial prompts and receives and validates the credentials and sends back the user specific data or error messages. So that is what the client communication handling has been happening in this particular function. Again, feel free to pause and take a brief look at the code that I had written here. And now, last but not the least, the main program flow. So here the main function sets up the server, including parsing command line arguments for port configuration, creating and configuring the server socket, and entering a loop to accept and handle client connections continuously. And then here we have the cleanup and resource management. So after communication, the client sockets are closed appropriately. So the program ensures proper cleanup, especially for Windows using WSA cleanup. Um, Now again, go back to the presentation that we have discussed about the server code, and now client code. So client code again plays an equal role, just like the server for this project here today. So now again, let's discuss the client code. Client code wouldn't be as lengthy as the server code. So here again, we have included libraries. So in the necessary standard inputs, string handling, networking, and time functions. Conditional compilation includes, different socket libraries for Windows and Unix like systems here. We have the socket creation. So this initializes socket libraries for Windows specific, and it also like creates a TCP socket for client, handling errors if socket creation fails. And now we have connecting to server. So this establishes connection to the server using the IP address and port provided. So it handles different methods for setting server address on Windows and Unix like systems. So error checking is performed to ensure a successful connection. And then we have communication with the server. So here it handles the main communication loop with the server. So it receives the initial messages, prompting and sending user inputs, like user ID and password. Um, Again, it handles several server responses and implementing a simple timeout mechanism. And it also allows the user to send a quit command to terminate the connection. So this is what the communicate with server function deals with. And now we have the main function. So it parses the command line arguments for server IP and port, defaulting if not provided. So calls functions to create a socket, connect to the server, and handle communication. Cleans up socket resources appropriately before program exits, with specific cleanup procedures for Windows, which is WSA cleanup. And now that we had, discussed in depth about both the codes, let's see the demonstration. I'll be showing you the live running of and the communication between the server and client here with the command prompts. So let's discuss aspect. So initially I had run the basic commands here. Um, this one over here. So initially make sure that the file path that you're in has the server and the client C files. So this command that I've been using here, SAP. So this is used for copying the server file from my local system to the remote server at the specified destination path. I had done the same for the client here again. And here if we see here at the bottom, so this command is used to compile the source code file, which is the vasireddy p1 server.c, and produce an executable file named vasireddy p1 server that we can run and execute the program. The same is again repeated for the client. Now I have two separate command prompts open. The left one, I'll be using it specifically for the server, and the right one will be used as a client. So let's, before running the commands, let me clean it and make it clear to just focus on the communication aspect and, make it look less cluttered. All right, so let's begin starting both the server and client. So first, let me start the server first, and I'm choosing the port number here as 9633, And now the server tells that the socket is successfully created, the socket successfully binded, the server is listening, it's waiting for the client to connect. So now let's begin the client side. Similarly, I had previously noted down the IP address, so I'm just typing it, the same thing down here, and then make sure that the port number is the same. So now, after it displays this way, let's quickly give the user ID and the password. Here we, all right. So what did we observe here? After we began the client side, I had to quickly type because the timer limit that I had set was just for 30 seconds. So I thought we'll delve into the functionality after I type. So which is why I had initially started the client, and the client says that it is connected to the server, and then the server displays that the server accepted the client and the client got connected. And now, before we type the user ID, it says that it's been waiting for 30 seconds to receive the user ID. So I quickly type the user ID from the list we had previously seen in the table. And now it says that the acknowledgement is received, and the server tells that it has received the user ID and it's waiting for the password. And now after we type the password, um, it says the received password is this over the server side, and it says that the server said the user validation is successful to the client, and now it displays the information associated with the particular user ID and password, which is account number and balance. And now the client is requested to type a quit message to end this particular connection. Now let's type that. And now the server has been waiting for a new client to connect. So now again, let's start a different client connection and explore different possibilities. So now I had typed the correct user ID, but I will type incorrect password, and now it shows the server tells that user validation is unsuccessful, and hence we could not retrieve any account number and balance details. So now let's type quit, and similarly, I will type an incorrect user ID and incorrect password. It says the same. So now let's, if we observe here, we can see that the server requested to close the connection and the client got disconnected as soon as we type quit message. So it says that the credentials are mismatched on the server side, and it received a quit message and closing the connection to the server, and now again it's been waiting for a new client to connect. So now let's understand the aspect that took me a lot of time to figure out, which is a timeout. So I had given a 30-second timer for each user ID and password separately. So I'm not going to type any password and wait for 30 seconds briefly before I proceed with typing any password. And if we observe here that the server is waiting, for a whole set of 30 seconds to receive a password, and let's see if it is actually waiting for the expected amount of time. Yes, it says that no connection occurred within 30 seconds, hence closing the connection to the client, and it's waiting for a new client to connect. Here, let's try typing some password on the client. No, it doesn't accept. It says that the client got disconnected and the password was not provided within the 30 seconds. Similarly, the same thing goes on for the user ID as well. I'm not going to type any user ID for 30 seconds, and let's see if it is functioning correctly as expected or not. Yes, there's no connection occurred within 30 seconds, closing the connection to the client. And if we try to type something on the user ID, it doesn't accept because it says that the username was not provided within the 30 seconds. Now let's explore the last functionality, that is quit. So basically, quit is designed to accept quit only in the capital letters. So let's also see that a scenario if that is working correctly or not. So let me type quit in small letters. It doesn't accept. Let me type a random thing. It doesn't accept. It accepts. It doesn't accept even a plain empty. So let me type quit in the capital letters as it is, as it has requested. And now the server requested to close the connection, hence the client is disconnected. So this is how the communication between the server and client happens. Now that we have seen the live demonstration, we're almost done with today's topic. So conclusion. So what did we understand here? So the efficient communication. So the TCP IP is designed to promote efficient communication over networks. So it accomplishes this by breaking down messages into packets and transmitting them independently and reassembling them at their destination. So efficient communication is ensured through proper routing, congestion control, and error handling mechanisms. And then we have customized solutions. So the layered architecture of TCP IP allows for customized solutions. Developers can implement protocols at various layers that are best suited for their application's needs. So without altering the entire protocol stack, this modularity enables the creation of specialized solutions while maintaining compatibility with the broader network. And then we have network troubleshooting. So troubleshooting is a critical aspect of maintaining a healthy network. So TCP IP provides, various tools and protocols such as ICMP for diagnostic and error reporting purposes, which helps in identifying and resolving network issues. And we have security enhancement in the last. So it is like security is not inherently robust in original design of TCP IP, but it has been significantly enhanced with additional protocols and techniques. Protocols like SSL, secure sockets layer, transport layer security, and internet protocol security, provide cryptographic security services at different layers of TCP IP stack. And that's it, you guys. I will be sharing all the resources of this project in the description below. Please do check out, and also feel free to reach out to me if you have any doubts and opinions regarding the project. And thank you so much for watching the video. See you all again.